Hello, we're going to do a little linear regression here on checkpoint 2.7. So first thing we need to do is, we're using the TI Inspires for this, so I'll pull up a TI Inspire and I entered the data. And so we have our X, which is what we call the independent variable, and or in real stats, in like AP stats, you'd call that the explanatory variable. And then in the y, so like the dependent variable, that would be like the response variable. But anyway, we need to type that into a calculator, we're using our Inspires, so we pop that into a spreadsheet and we go ahead and label each column, price and sales. So I went and entered that, and to find that, if you're totally new to these, to find that, you just would go home, and it's this green icon right in the middle, looks like a table. That's a spreadsheet, but I'm going to go back to what we had, so I'll go back to current. So from here, now to run that linear regression, because we're going to try to find that like calculated line of best fit here. And to do that, we go into menu and stats, and stat calculations has a whole bunch of options, and one of them, number 3, is linear regression mx plus b. Okay, if you did a good job naming your list, it should be in here under the X list. And remember, we wanted price for our X, and for our Y, our dependent, we wanted sales. So the number of sales depended on the price. Okay, and that's going to save our regression equation to F1, so you're going to make sure to know that later. That's going to be like function number 1. You could kind of think of it as like that. Alright, so that'll be important. And then also to go down here and pay attention to what column it's going to print your data out in, or return your data to your spreadsheet. And that would be column D. And sometimes if that gives you a column where there's information in, it'll say, do you want to overwrite this data? And you may or may not. So just pay attention. D is going to be fine because we don't have anything in D. Alright. Click OK, and there we have a whole bunch of extra data. It started in the D column like it said it would. And so if we go up here and take a look at this stuff, what is all of this? Well, we have M, right? And we know what M is. As far as y equals mx plus b, that's the slope. So that's going to be the slope of our best fit line, our regression line. We have b, which is the y-intercept of our regression line. And then we have this newer concept down here, R, which is a correlation coefficient. So those kind of move there, but R, we talked about R, remember? And R is some value. Okay, that's going to be less than or equal to 1 and greater than or equal to -1. And the closer it is to 1 or -1, the stronger of a correlation you have between your points. Kind of meaning like if you had a correlation of exactly 1, those would be perfectly linear, which is super unrealistic. Okay? Alright, if you had a correlation of like 0.9 or something, well, that would be a scatter plot that would have positive association, but it'd be pretty strong. Okay? If you had like an association or correlation of 0.7, you'd still see some positive association, but it might not be that convincingly strong. It might be a little more scattered, spread out. Alright, but the main point is just understanding that the closer you get to 1 or -1, the tighter those points are together, linear speaking. Negative points, remember, if it was -1, that would be a perfect line going in the negative direction, like a negative slope. So R is sort of indicating how well those points are correlated. Okay, so that's all we've really done there, and then we've used the line to predict. So if I go back to our checkpoint, what are we going to do with this? Okay, well, we want to record the regression equation, and then we want to record the correlation coefficient, which the correlation coefficient was that R value. Right, so we know that, and then we want to predict for $205,000. Well, remember I told you F1 was the function, so we want F1 of 205. Okay, and then I want to graph the scatter plot and show the regression. So the regression equation is going to be y equals something x plus something. Alright, so let's go back to our calculator and let's show you how to do that. So if I go to a home and I go and pick out, open up a new graph. Okay. Notice that it gives me an entry bar that starts with F2. That's because F1 was saved. So if you click up one time, it will bring you to that F1. You can hit enter and graph that puppy. It doesn't show up because the window is not zoomed correctly right now. It's only going from -10 to +10 and up 6 2/3 and so on. So we'll get to that here in just a second. Let's go ahead now and graph the scatter plot. So everything's pretty much in the menu in these calculators. So go to menu, graph entry, edit, and then down to scatter plot. And we can go now and import those lists from this button right here, this var button. Okay, that's where stuff is stored. So in that var button, I'm going to go in there and I'm going to click in there, and you see I got my price and sales list. So I can go and put the price in for X, pop down here, hit that var key, put the sales in for Y, and then go ahead and enter, and that's going to graph all those points, that scatter plot. Still can't see it because it's not zoomed, so let's go ahead and zoom. Menu, window, zoom, and then if you go down to zoom data, it'll zoom right in where that scatter plot was. So there you go. Now you see our scatter plot, you see the line of best fit in here, the regression line. You can move that around if you want to. And so now we can go ahead and record our regression. We have -0.793x. I'll go back here. -0.793x to the nearest thousandth would be sufficient. And then plus 250 point. I wonder what that is. If I click on it, it'll show up above. So 0.793 and 249 point. Actually, it's 249.857. So plus 249.857. And that just goes out for decimal points, way, 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 way out there because the calculator does it. All right, we'll go back to our spreadsheet here and just see, whoops. Let's see what our R value was because I didn't record that. Negative, so our R value, again, that's right here. Okay, that's -0.954. Okay, pretty good. So go back over. -0.954. Just put a 0 there, Mr. Bolio. Come on. It's early in the morning right now. It's early in the morning. I'm recording this from Alaska. So it's been dark for 10 days. There we go. I think that was right. So now the last thing we got to do, we have our, let's do a checklist here. We have our equation, check. We have our R value, check. You know what that means. That's a really strong negative correlation. Now we need to put in our prediction. So we're going to make a prediction for 205. So we're going to use the line to make a prediction. Okay, so let's go back to actually home. This is pretty slick here, watch this. Go back to home and open up a calculator page now, this one. Okay, so I'm gonna type on this one here, open one of those pages. All right, well now, since it's saved as F1, watch all I have to do. F1, parenthesis, and then I wanted 205. 205, enter, and voila, 87.32, so 87 homes, round down, because we're just talking about homes. You're not going to sell 0.3 of a home. So go ahead and round down to homes. So that's going to be 87 homes. But it's actually, well, I guess it is 87. 87 homes. All right, so can you do all that on the calculator? We did that a bunch of practice in there. Hopefully if you missed or something, this kind of helps. And you know, if you need to come in and use a calculator to practice that, no problem. Come on in.